Hello everyone, my name is Rudra Vengurlekar. Today I am going to present my project about modeling and control of residential HVAC systems as a part of BS 613 Modern Control Theory course. So the residential HVAC system considered in this project consists of an AC, air handling unit and a humidifier. The objective here is to maintain the indoor temperature and indoor relative humidity levels close to the set point values. There are multiple disturbances present in this residential HVAC system, which are outdoor temperature, outdoor relative humidity, indoor heat generation, indoor humidity generation, and outdoor solar radiation coming through this window. This residential HVAC system can be modeled using energy and mass balance equation. There are mainly four states of this residential HVAC system, which are indoor temperature, outdoor wall temperature, indoor wall temperature, and the mass of water vapor present inside the room. From the energy balance equation, we can get an expression for indoor temperature change, which is dependent on the flow rate of AHU, infiltration rate lambda, the flow rate of AC, the heat transfer due to convection at wall, and the indoor heat generation rate. The walls here are modeled as a resistance capacitor model. Thus, the equations of the outdoor wall temperature, indoor wall temperature are calculated based on the resistance and capacitors of the wall, which are calculated using these three equations. Coming to the mass balance, the amount of water vapor present inside the room changes with time, and that rate of change is dependent on the flow rate of AHU and the infiltration rate lambda. It also depends on the absolute humidity outside and inside the room and the density of outside and inside the room. The absolute humidity is a function of saturation pressure, which is a function of indoor temperature. Here phi represents the relative humidity. The density is calculated by assuming the air as an ideal gas. The mass of condensate getting condensed inside the AC is also calculated over here. Apart from that, the humidity generation rate provided by the humidifier is also there in this expression. The aforementioned ordinary differential equations, the linear approximation of this equation is taken to get the state space model of this format: x dot equals to ax plus bu and y equals to cx plus du by taking the Jacobian of the ODEs. And this linear approximation is performed around this operating point, the nominal operating point as given in this slide. After getting the linear approximation, we get the linear time invariant model where A, B, C, D are the matrices consisting of constants. The stability of the system is analyzed using the eigenvalues of x dot equals to ax equation. It was observed that all the four eigenvalues were negative, which means that the system is asymptotically stable. Thereafter, the Lyapunov function the expression A transpose P plus PA equals to minus Q is calculated by considering Q equals to I4. We got this matrix P as a result. Here the matrix P is positive definite matrix and it is symmetric. Thus, the system is stable in the sense of Lyapunov. To assess the observability and controllability of the system, the observability and controllability matrices are calculated. It was observed that both are full length. Moreover, the observability and controllability grammions are calculated, which are shown here in this slide, and both of them are positive definite. Thus, we can say that the system is completely observable and controllable. Using the pole placement function in MATLAB, the desired poles as shown here are placed to get the value of k, and the closed loop simulation are performed. The closed loop simulation for an initial condition is shown here. The dotted line here shows the set point values, and the blue line shows the actual expression. Here the T out 1 is indoor temperature and T out 2 is the indoor relative humidity. And as you can see, both of them are getting close to the set point values. The closed loop simulations were performed for step and impulse responses, and it was observed that the controller was able to bring back the control variables to their set point values. In conclusion, the system HVAC system considered here is asymptotically stable in the sense of Lyapunov. It is completely observable and controllable. The closed loop simulations shows that the controller was able to bring the indoor temperature, indoor relative humidity close to set point values under initial condition response, step response, and impulse response. Thank you.